So the last lecture was all about parallel plate capacitor. So we saw, okay, how various connection will result into different charge distribution, and we tried to find the charge distribution for various configuration of parallel plates, in which we sorted some plates and we saw that how it affects the overall distribution. At the end, towards the end of the lecture, we also talked about something called dielectric, and we saw that how our presence of dielectric enhances the overall capacitance of a capacitor. We saw some of the examples in which we only introduce the constant dielectric or dielectric with constant dielectric constant, so much constant here. So the dielectric constant is, or you can say the relative permittivity was constant, and it was filled between the plates. And I think we just saw few examples. One when it is completely filled, and then we put one after the other as a series combination. And we also found the effective K value for the given pair of dielectric. So we are going to do more questions based on the same. So the next will be, what if the dielectric is filled across the plate covering 50% of the area? So the terminal is here. And of course, later on you will see a very simpler way of doing this, but right now we are applying the definition to get the answer. So imagine if you have a situation like this in which half of the area is faced by the dielectric constant K1, and similarly A by 2 is for the K2, and the separation between the plate is still D. So symbolically it's the same. You can see the plates are left and right, and so are the terminals. Now the question is, we are supposed to find the C equivalent. Okay. So our method is like we always give some charge to plates. You can give charge plus Q to one and minus Q to other. And now the first question is, whatever charge we give to the plate, will it distribute uniformly, or will it distribute non-uniformly? So what do you think, guys? The distribution of the charge on the plate is going to be same everywhere, or will it change, or will it differ? I think the voice is not audible. Can you speak closer to your mic? Pardon?
Will it change?
Right. So if it will change, then why? Why this will change?
Yes, sir, because we have two mediums of different permittivity.
Yeah.
So one will oppose more comparatively to the other.
Okay.
Yeah, because they're gonna like permit different amount of charge to distribute through them.
Yeah. So why it should be different is the simple answer. the potential difference between two metallic conducting plates cannot change whether you go from the top or you go from the bottom. If we have two plates, then the entire volume of conductor is equipotential. So the potential wise, the entire plate must have same potential. So let's say if you move like this. Now if the plate is creating E, the moment you enter the field will become E by K1, correct?
Yes.
But if the plate is creating the same field here also, here it will become E by K2, right?
Yeah.
The problem is if you walk across the D length, the potential difference from the top becomes E by K1D, and from bottom it becomes E by K2D, isn't it?
Yeah.
What does it mean? There are two answers for the same plate, which is not possible. It means the charge distribution will change in such a way that E1 above and E2 below. So the plate above this line will produce, let's say E1, the plate below will produce E2, such that E1 by K1 and E2 by K2 turns out to be same value. Understood?
Yeah.
So what we need is we need the resultant field to be same in each case because we are traveling across the same distance. So what must be same is the resultant electric field between the plates. So the resultant E net here and E net, and E net is written as E plate by K1. If we choose the same EP and if we divide by K2, is it possible to be, is it going to be equal? No.
No.
So I must change E dash P. It means the plate facing this part is developing a different electric field than the plate facing this part. So what will happen in reality? If I draw the plate, if you look at the plate part, so if you look from this side, so if you look at the back side of the plate, you see that the charge will distribute differently. It will be Q1 here and Q2 here. So we won't get the similar distribution, rather we will have a different distribution. So the total charge which you gave as Q will divide itself in the fashion like Q1 and Q2, such that this part will create a field EP and this part will create a field EP dash. But the net value, which is EP by K1, must be same as EP dash by K2. So the rule is simple. The potential difference will be E net into D between the two plates, right? And this we can write as and now if we have the plate with charge Q1, EP we can write as how much? The EP will be the charge upon area upon epsilon naught, Q1 by A by 2 epsilon naught, isn't it? Do you realize this? Sigma by epsilon naught formula?
Yes.
And the EP dash will be similarly we cannot get 2Q2 by A epsilon naught, isn't it?
Yeah.
Yeah.
Okay. And what else we can see? And trust me, I'm solving by the most difficult method. Why? I don't know. Maybe, but that's my intention is to show you the basic method. Yes. You won't get the chance of studying all this thing in any textbook. That's the problem. So EP by EP dash will comes in the ratio of Q1 by Q2, Q1 by K2, and because EP and EP dash we have already written, the ratio of charge will be in the ratio of dielectric constant. That is very nice relation. And therefore, because we know the ratio and we know the summation, so from 1 and 2 we can find Q1, Q2, right? So what is Q1 going to be? It is K1 upon K1 plus K2 into total charge, right? I hope you know how to solve ratios and proportions. If you don't know, you can borrow your cousin who are in class 6 and try to study. Unfortunately, it is not part of JEE syllabus, but we will get somewhere. So after doing all this hard work, we got Q1, we got Q2, and therefore we can now find the E net by using any formula because it's going to give you same answer. So EP D by K1. Let's substitute everything. EP is how much? 2 Q1 by A epsilon into K1 into D. And basically, the net turns out to be how much? What is this? EP by the D will not come. I just wrote a D here. Okay. So EP is 2K1 by A epsilon K1. That's fine. So E net is how much? 2 by A epsilon naught K1. And Q1 itself is K1 upon K1 plus K2 into Q. So the E net turns out to be K1 gets cancelled 2Q by K1 can get K1 plus K2 epsilon not A. That's simple. So after all the hard work, we got the E net value. And now we can add the delta V. The potential difference will be how much? E net into D, which is 2Q by that is yes, into D. So Q by delta V turns out to be K1 plus K2 by 2 epsilon not A by D. And by definition, this is called the C equivalent, right? Okay, so this is something you can, if you want, you can practice. If you don't want, that's totally okay. I will not say anything. All right. So this is the C equivalent formula. And by looking at this, you can clearly say, what is the K equivalent?
K1 plus K2
K1
by
plus K2 by
Last time, what was the answer that we got earlier?
2 K1 K2
K2.
K1
Correct,
plus.
correct. Okay. So what I'll do is, We will not solve every question which is scratch. We have many nice trick. So before that, I will give you a simple thing called grouping of capacitor. Then we can use those formulas directly. Okay, so the first question is why we need to know the grouping of capacitor. Why grouping is required? Any idea?
Try to increase the capacitance of the system.
It is actually a commercial reason.
Okay.
It is like we cannot manufacture every capacitance that we need, right? So when it comes to the manufacturing, we only manufacture certain finite values, and then those are sold in markets. You can go and buy those capacitors, and then you can rebuild your desirable capacitance. So grouping gives you a way to understand that, okay, if I have let's say 1 microfarad capacitance or capacitor given to us, and there is no dearth of the number of capacitor, so you may give hundreds or tens or thousands of such identical capacitor, and then you will tell me, okay, can you give me 2.5 microfarad capacitance? So you cannot cut one capacitor into half and then stick somewhere, and it is not like that. So to achieve a certain value of capacitance, we must know how grouping affects the net capacitance. Will it increase or it decreases, or what else we can do to achieve it? Okay. So the whole idea is that by knowing the grouping, we can achieve a desirable value. Okay. Also, we will learn, okay, that every capacitor in a circuit need not to be holding the charge. So we have some neutral capacitor present in the circuit. So we should be able to eliminate. So grouping is something which gives you all the ideas which you need to know in order to create a desirable capacitance using the commonly available capacitor. That is the whole, or you can sole idea of learning this topic. So in grouping, there are two types of grouping which you know. Particularly, one is called the series grouping. Just so anything which is neither series nor parallel, we try to convert into one, which can be eventually converted into series or parallel. So that then only we can solve. So we will see a variety of circuits in which the capacitor will be available in a variety of ways, and we'll see how we can use it. So what happens if we have series combination? So we'll start with the series combination. It's pretty simple. I hope you have seen before something like this in current chapter in class 10. But nevertheless, we're going to learn from basic itself. So in series grouping, what we do? So we bring multiple capacitors. So 3 is good enough? Maybe. So when we drew capacitor as a circuit, so we got the inspiration from the parallel plate. So we draw like two lines, and you can keep one of the line as curved also. It doesn't matter. So when you are drawing with a free hand, we use the curve symbol. Because if you draw two lines and if you fail to draw properly, it may look like a battery. So that's ambiguity may arise. But if you make it curved, then we know it's capacitor, even though it's not equal. So in various, you can say literature, they represent differently. In print, because the vertical lines are easy to print. So in print, you will see mostly this. The old authors, they use curve. It varies across different literature. So I won't say that there is only one way. All right. So now we have a capacitor. So first of all, we need to understand that the battery will have some polarity plus and minus, and we'll check for the plate which is physically connected to the battery or the cell. So which plate is physically connected? You can see if I number it for the sake of reading purpose, let's call the numbering as 1, 2, 3, 4, 5, and 6. So we have 6 plates, and the positive terminal of the cell is connected to the plate 1, and the negative is to the plate 6. Okay. So 1 to 2, 3 to 4, 4 to 5. I mean, okay. So now this, if you look at the cell and if you look at the positive terminal, the plus is connected to which plate? Plate number 1. What about the negative terminal of the cell? Plate number 6. And if you look carefully, that's a challenging job. If you look carefully, you will see that this plate, this pair of plate, is technically isolated, and this pair is also isolated. Do you realize this? These two plates or these two pairs are independently isolated, which means they are not physically connected to anything, isn't it?
Yes.
And because they are not physically connected to anything, then how charge can go there? Through what mechanism charge can go there? That's a big question. So no charge actually goes there. That's the reality. So what exactly happens here? The negative plate, the negative terminal of the cell will pull some charge from 6 plate. So some charge will be pulled like this Q. And therefore there is a defensive charge which we represent by minus. So actually you're taking, it was neutral and you have taken some positive value. So what is left there is in excess negative, isn't it?
Yeah.
And the same charge you give back to the plate number 1. This is the only physical flow of charge. So what a cell is doing? Cell is taking a charge from plate number 6 and giving back to plate number 1, and In doing so, of course, it will perform some work, but we'll talk about the work later on. But once the charge is kept on the plate number one, the battery will stop the reverse flow because it will oppose it to come back. So this is the basis of charge flow. After this, there is no flow. After this, what you see is called induction process. So what will happen? The plus will induce a minus charge. This minus is appearing on one of the plate, and because the other plate and this plate 2 and 3 are isolated, so the net induced charge on any isolated system of plate is always
0.
so this is bound to get the plus, isn't it? Basically, this plus will pull the charge towards its, I mean, the negative charge. So the other plate will have deficiency of electrons, or you can say other plate will have plus. So the plus and minus is resulting here as a, like, this is as a result of induction process. Is there any physical flow there?
No.
No.
No, there is no physical. So it is due to the plate. That is the whole idea. Imagine if I remove the connection, then how it will pull? Because now if I remove the connection, we have how many isolated plate? We have
One.
2, 3, and 4, 5.
Oh.
There are 3 pairs now. Because then plate 2 itself become isolated.
Yes.
Plate 3 itself become isolated. Plate 4 and 5 together become isolated. Yes or no?
Yes.
And in that case, there is a difficulty. So this representation of charge is misleading for many. Why it is misleading? Because in reality, I'll just remove this. In reality, in circuit, when you represent the charge like this, the charge which we show here is only the facing charge. These are facing plate charge. These are not outside. But in circuit, we don't draw plate, we draw the circuit symbol. So we show it outside for the matter of convenience. It is not the reality. It is not actually appearing there. Is this clear? So where are these charges actually? On the facing surface. Understood? The outer surface can acquire charge only when if you give charge externally, because we know that half of the charge will appear outside and half will appear outside, and then it will follow the charge conservation rule. So this plus minus way of representing is misleading, because you may think that, okay, I am giving charge to the outer plate. No, there is no plate here actually. There is no plate. These are the circuit symbol of capacitor. And you may get confused that the plate symbol all are different. But because they look same, that's why I said the curve way of this way of drawing is much better than drawing like this. So this is the symbol for capacitor, and no matter which capacitor, whether it is parallel plate capacitor, whether it is spherical capacitor, whether it is cylindrical capacitor, whether it is some inclined plate capacitor, whether it is some randomly shaped capacitor, this symbol belongs to capacitor. Now, which capacitor we don't know, because our inspiration has come from the parallel plate. That is why it looks like that. Okay, I hope this is clear. So now, because I'm not going to deal with scenario in which the facing plate and the outer plate will have this, separate charge. I will discuss that in a while as a separate topic in which both possibilities are there. But what you need to remember as a thumb rule, a battery always gives equal and opposite charge. As you can see, the 1 and 6 got equal and opposite. And therefore, this question is similar to 1, 2, 3, 4, 5, 6, in which you give here plus and you give here minus. So what will appear here? 0, 0. Okay. And because it is 0, then it will be how much? All plus here. Isn't it? All minus here. Yes or no?
Yes, sir.
And now induction will happen. So this plus will induce minus here. Okay. Because this plate itself is isolated. So what will happen? This will appear plus here. Then again minus. Again plus. But here. We have some connection here. One connection. So when minus will appear here, then what will happen? We know that if minus will appear here, then plus will appear here. And then again induction minus, then induction plus. So where are the charges actually? Actual charge representation on plate. But in circuit, we represent it like this because it is matter of convenience. So as a thumb rule, whenever a cell or a battery supplies charge, that charge can only appear on the facing plate. It will never be part of the outer side of the parallel plate. Is this clear what I'm saying? Now this plus minus will again, this plus will induce minus here. And this will induce plus here. The reality versus the diagram here, I mean, I know it's confusing, but please don't get confused. Okay. So technically, this is the reality, but when we study circuits particularly, we say that the battery has given charge Q. And we never talk about the charge taken. So what really matters is who has given. So the positive terminal is giving. So the one who gives, we only remember that. The one who takes, we never. Okay. So it is like someone is pickpocketing and doing the charity. Okay. But we only remember the charity, okay, because pickpocketing is something hidden. We don't see from where he accumulated that money, but you see at the end, okay, he is doing the charity because people generally show off doing charity. So in a similar fashion, this battery is doing the same job. It is taking from one, giving to other, but what we need to remember is that it is giving to other. And what really matters is the plate which is connected to the positive terminal of the cell, which is plate 1 in this case, right? So what do we say? That plate is giving charge to 1. And how much charge it is giving? Q. And because of induction, this is also Q, this is also Q, isn't it? Because of induction, this is Q, isn't it?
Yeah.
And because every pair of plate is having charge Q in the facing plate, so it will also develop some potential difference. Let's call the potential difference as across this as V1. Oh, this is too thick. V1, V2. These are the potential difference. V1, V2. V1, V2, V3. Is this clear so far?
Yes, sir.
Okay. So the way of thinking, or while solving numerical circuits, how we think is that this flow of charge Q is flowing here, and coming back. This is how we think. Of course, there is no flow, but this is how we think because that's, again, it's a matter of convenience, how you perceive the same event. So we say that a charge plus Q has been given by the cell and the charge has appearing. So physically, which plate has gained the charge? Only the plate number 1.
1.
So if I ask you how much charge is given by the cell, what is your answer?
Q.
It's only Q. We should not say 3Q. This is a general perception that people say 3Q many times. So when I ask you what is the charge given by the cell, the answer is only Q.
Q.
The rest are induction. The rest are not given by the battery or the cell, right? And if I ask you what is the net charge given by the cell to the circuit, the answer is 0. Circuit cannot give charge. Cell cannot give charge to circuit. So when I say charge given by the cell, it means charge given by the cell to the plate which is connected to the positive terminal of the cell. That's how you need to remember. So what is the meaning of charge given by the cell? It is the total charge which appears on the plate which is physically means electrically, I would say, which is electrically connected with the positive terminal of the cell. Is this clear?
Yes.
Yes.
So what is the charge given by the cell meaning?
Charge which appears on the plate,
Which is electrically
which
connected
is
to the circuit.
electrically connected to
Connected to the not circuit, to
positive
the positive
terminal.
terminal of the cell. It's a long literature. Shall I put it in words? I think so. I'll put it here, not an issue. So meaning of charge given by the cell, right? It is the charge given to the plate connected with positive terminal of the cell. Okay, that's fine. Okay, this kind of meaning one should be aware of. And that is why this chapter is very, very difficult for many. In fact, electrostatics is quite easier compared to this. Because you need to know a lot of things.
Sir, the sum you were telling of advanced 22, I solved it. It wasn't that tough. The
Of course,
capacitance question, dielectric.
JEE questions are not difficult. I am saying my questions.
Okay.
Yeah. So JEE always asks easy questions. Except sometimes, and see, the irony is whenever JEE has tried to ask tough question, it has failed. So this year also they tried to ask one question which is slightly tough. Then eventually they get bonus because they themselves made the mistake in giving the answers. So okay, they try to become over smart sometime, but because nowadays people who are creating questions are not very smart. They are very, very mediocre guys. IIT is filled with very bright professors who are not given job of creating the questions. Now the newcomers who are very young, they try to create, and while doing so, they often make many mistakes. But nevertheless, it will eventually change. Still, that is right. Okay, so I hope the basic idea is clear, like how the charge is flowing, how we should understand, and how the charge actually appears versus how the charge will represent. Those differences should be in your, you should be borne in mind while solving numerical. Okay, all right. And a positive plate we always assume at high potential and negative at low potential. So when we move from high to low, the potential will drop. And we know the relationship between the potential charge and so what we can write? If charge is same for all, so charge is represented as product of capacitance and the potential difference, isn't it?
Yes.
So Q
Yes,
is same. Now that is our first knowledge. We know that Q is same. So we can write Q equals to C1 V1, C2 V2. Oh, why am I adding? Equals to, my bad. C2 V2 equals to C3 V3. So if you want to know only V1, the value, it's Q by C1, Q by C2, Q by C3, and V1, V2, V3 are potential difference values. If you want to know the direction in which it is positive and negative, that depends on how you walk. The next concept is how the potential of the cell is related to V1, V2, and V3. So if I say this is V1, or let's say this is at a potential X, this is at potential Y. So if you go from bottom, from X to Y through bottom side, the difference itself is V, right?
Yes.
Yes, sir.
So the way one should think of writing is like this. You start with X, then you walk, 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 walk. Then you see the high and low, so you drop to minus. And you drop by what value? Value of drop is V. And once you drop, you are at this end, and then this potential is given as Y. This is how we think. Okay. So as long as you're moving the wire, there is no drop. But once you cross some element, there is a chance of drop or rise. And that is why we can say X minus Y equals to capital V. But if I do the same thing while moving upward, so I'll move like this, I'll drop, drop. Okay, nothing. Okay, I'll show you better. So nothing, 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 then drop. Very bad. Then you cross, you drop. Then you cross, you drop. You can just do it like something like this. So if you start with X, the moment you cross the first capacitor, the drop will be how much? V1. And when you cross the next one, again there's a drop.
V2,
Then again there's a drop.
V3.
And after 3 drops, you are exactly at Y. So X minus Y we can also write as V1 plus. So X minus Y, basically the sum of potential is nothing but the potential of the cell. I mean voltage of the cell. My bad. I make many mistakes. Okay, so the formula, see, these are not formula, it's like common sense. So we can add V equals to V1. That's a simple question. The next part is what we are trying to achieve. We are trying to achieve the net, or you can say equivalent capacitance. If you try to achieve the equivalent capacitance, what does it mean? What is the meaning of finding the equivalent capacitance?
And how many capacitors we can replace by one capacitor to get the same result?
Which result? What do you mean by result? What is the whole idea of result? Tell me.
Like to store that particular amount of charge.
Exactly. The result only means the charge must be same before and after. The whole purpose of capacitor is to store charge. There is no other purpose. There is no other charge. I mean, there is no other purpose. So if a cell is given a single capacitor, it is going to be called equivalent if it allows the similar charge to be deposited as the previous case, or as the combination together was allowing for the cell to give. So the Q is the guiding principle. The charge stored must be same. Similarly, when you are solving the circuit in which you're trying to find the current, equivalent resistance is the one which can give you, which can let the cell to deliver similar current in the circuit as done before. So in this case, this entire charge Q will deposit here, and this Q we can attach C equivalent into V. That is the whole thing. And now we can substitute V, we can attach Q by C equivalent, and V1 we can attach Q by C1, Q by C2, Q by C3, and we are done. So 1 by C equivalent is 1 by C1. So in series grouping, the formula is something like a parallel equivalent of a resistor. They are following the opposite sense. What capacitor follows is called the combination of spring, because the role of capacitor is exactly same as the spring. Why they are having same role? So if you remember, a spring can store potential energy when you compress, right?
Yes.
When you deform, isn't it?
Yeah.
So what is interesting? What is the energy stored in the capacitor in the spring? Half.
KX.
Now the electrical equivalent is that that 1 by C act as K, and charge act as displacement. And if you substitute, you can get the formula. The energy stored in capacitor is half K X square, which is very nice to easy to remember. Both will store the potential energy, and the idea of displacement we can substitute in terms of charge, and the capacitance will be inverse of K, or okay. So how we have tried 1 by C inverse, because K means how tough is the spring, and when I say tough, it means it's very difficult to compress. So a very difficult to compress means very difficult to give charge, and very difficult to give charge, it means very less capacitance. Okay. So if C is really small, 1 by C is really large. It's the same idea, right? Okay, you didn't get this. Anyway, so you will realize that formula of the series grouping of spring will follow the same formula. If we have springs in series combination, in this case, if you pull by force F, and if you try to replace by equivalent, if you pull by same force, what must be same? The displacement. Just like here charge was same, here the net displacement must be same. So let's say if this will elongate by x1, this elongates by x2, this elongates by x3, this elongates by x, then the x must be same as
X1 plus X2 plus X3.
just like this. Okay. And having same charge is like having same force here. I mean, the idea will change. So anyway, what you need to remember is this is of course for mechanics. I will not going to teach you this part. So 1 by K equivalent is it is the reverse process. I mean, if you want to remember, you can remember in the other way around. If you know the spring formula, you know the capacitor formula. That's anyway. Okay. So 1 by C equivalent is 1 by C1 plus 1 by C2 plus 1 by C3. It's pretty simple. I mean, you know how to derive this, and for n identical capacitors, if all capacitors are identical and connected in series, you can add 1 by C, 1 by C, 1 by C, let's call n times, right? So what will be the C equivalent? And this gives you some idea. What it gives you the idea? The equivalent is going to be very small or very large. So in series grouping, what do we do generally? Do we increase the capacitance or do we decrease the capacitance? Tell me. In series grouping, what we do? Do we increase or decrease the capacitance? Huh?
Decrease.
You mean DECREAC, right?
Yes.
Yes.
It will decrease. So what is the purpose of doing the series grouping? If you go and buy a capacitor, let's say the shopkeeper says that today I don't have the smaller values. Can you take the 10 microfarad capacitors? I mean, tomorrow I'll try to make it, but you need it urgently because you want to make your circuit and you want to set up your Alexa, or you want to design some circuits for other purpose, DIY. Okay. So what will do? We go to market. I mean, the shopkeeper will say that, okay, I have only 10 microfarad. You will buy all the 10. Let's say, give me 100. Come on. And you will join all the 10 microfarad, 10 such capacitor in series. It is as good as 1 microfarad, right? Understood?
Yeah.
So using 10, you can create one.
Yes.
And you know that to create a smaller value, I need to connect in series, right?
Yes.
Yes.
But now you want to increase. Let's say you want to have the 2 microfarad. So you will make such 10, 10, 2 layers, and you will join in parallel. Then you will become 2 actually. Okay. And then you realize that, okay, you need 1.5. So, okay, 1.5, which means 2 is more, 1 is less. So to get 1.5, what will do? There are many ways. Of course, what you can take 20 in series, that will become 0.5. And then 3 such in parallel, it is 1.5. The idea is because the series decreases, and what you need to remember that in the series combination, the equivalent will be less than the least of the values. So if you take 1 micro, 10 micro, and 100 micro, and if you connect in series, the net is going to be less than
1.
1. In parallel, it is opposite. It is more than the maximal. So if you have 1, 10, and 100, it is going to be more than 100. In fact, you will get 111 as answer. So in series grouping, the effective value will be very small, and it will be not just small, it will be less than the least of the values available to you. So if you go and buy 2 micro, 5 micro, 6 micro, the answer is bound to be less than 2. If it is in parallel, sorry, if it is in series combination. Okay, this is something very simple. So that's why something whose values, I mean, if we have only one plate, definitely I cannot put many charges because there is only one plate. But putting charges in series, I mean, sorry, capacitors in series, why you decrease the value? The answer is even the battery will try to give Q, all will start repelling at the same time. That is the problem. So they will not let the charge to move. It's like the repulsion will be tremendous. Understood? So all in series will repel more. That's whole idea. Anyway, so you can take some more examples. This is a pretty simple. I don't know why I'm giving so much time. For 2 capacitors, 1 by C equivalent is how much? So this C equivalent is going to be less than the least value, isn't it?
Yes.
If you do the same thing in case of masses, if you add inverse of mass, it is like a parallel combination of masses. So mu will be less than the minimum of the two. Correct?
Mhm.
That's mathematics actually. And that is why this is called reduced mass. Why I gave this answer? Because one asked why it is called reduced mass, because it is actually reduced in value compared to any value which you take. And reduced mass is not for only two masses, you can keep on adding like this. So this is the reduced mass of the system of all the parallel masses. Okay. So we use the idea of reduced mass to solve the laws of motion question in a like a formula, like a trick. So anyway, there are many questions of a system which we can solve using the reduced mass. So reduced mass is a concept. So whenever you have capacitors in series, it will always produce the value which is less than the least value.
Least.
Well, that's a simple line. And if you have not written in high school, then write it here. What I write? In series combination, equivalent capacitance will be less than anyway. So let's say if I give you 2 microfarad and 4 microfarad, what will be the parallel equivalent? What is the C equivalent? Sorry, parallel series equivalent. My bad.
4/3.
4/3, right?
Yes.
If I give 15 microfarad and 6 microfarad, then
90/20. Uh, 30/7.
21 microfarad and 7 microfarad.
21/4.
Very good. So this is very easy. Okay. So the other way of thinking is again it's a basic maths. You can also write as C2 upon. So big upon small plus 1. Take the ratio of big and small. If it is divisible, whenever the big is, let's see if I write 81 and 9. So we know that it is divisible. 81 by 9 is 9, right? The answer will be big upon the ratio plus 1, which is 10.
10.
It's just like a trick of, it will help you in doing the calculation faster. So if I give you 3 microfarad and 12 microfarad, the answer is quickly, without using pen, you can tell 12 by
5.
so 90 microfarad and 15 microfarad.
90/7.
It's very fast, right?
Yes.
So same mathematics, but if you do in this fashion, it's very effective, very fast. Understood?
Yes.
Okay, just a small practice. I mean, if you know this, this is. So generally they'll give you, okay, what is the 2C and C? 2C and C?
2 by 3.
2 by 3.
2C. And 6C and 3C. 3C.
6 by 2.
2C, right?
Yes.
So you can see this is really fast. I mean, it saves some time. Coming to the next one, parallel combination. Okay, so again, similar thing. Now, if you look carefully, the positive terminal of the cell is now physically connected to how many plates? You can see it. How many plates are connected physically to the physical means electrically to the positive terminal of the cell? One plate, two plate, three plate.
So 3.
So you have really big space to now put charge, right?
Yes.
Just so now whatever charge you give, which is like a huge volume. So we have three plates. So the charge will come at this location called junction. We'll come to that later on. And this charge can now divide into three parts. I don't know exactly how, so I can call Q1, Q2, and Q3. Okay. So let's say the first capacitor acquires charge Q1, second Q2, and third Q3. So here nothing is isolated, everything is connected physically, or to be more precisely, electrically. And therefore, what we can write here? So the charge which is given by the cell is how much? So we can write Q equals to. Am I audible, guys?
Yes, sir.
Yes, sir.
There are a lot of noise coming, huh? Just today is Ganpati Visarjan, so that's why. So Q equals we can write as Q1 plus. Am I audible? Hello, hello.
Yes.
Yes, sir.
So we can write this question, right? This is called the conservation of charge. Or you can simply say the total charge coming here, Q will divide, and therefore, and because charge is conserved, so the Q is equals to Q1 plus Q2 plus Q3. Later on, we'll come to this is called Kirchhoff's current law in the honor of Sir Gustav Kirchhoff. Anyway, so this is called KCL in short. Kirchhoff's current law. We'll come to that. Now, what you are trying to achieve? So you can look at this carefully that all the plates of the left plate of every capacitor is having the same terminal, and all the right will have same terminal. Because they have the common terminal, so potential difference must be common, isn't
Yes.
it? So X minus Y must be equal to V from bottom, and it is similar to what? Q1 by C1, Q2 by C2, Q3 by C3. You can write like this, right? So across any capacitor, the voltage remains same. So charge will distribute in such a way that the ratio of Q and C will give you the same voltage, which simply means Q1 equals to C1V, Q2 is C2V, and Q3 is C3. And eventually what you want? You want so C equivalent means the battery will give the same charge, which is again Q, correct? Q is also equal to C equivalent to V. And once you got all the C, Q1, Q2, Q in terms of C, V, because that is a common value, use the KCL to get the answer. So you can substitute there. So what you can substitute Q as equals to? Q1 is how much? So the whole simple idea is we express the answer in terms of common variable. And here V is the common variable. So V gets cancelled, what do you get? So it is simply like more plate, more charge you can store. So it will add up. So in parallel combination, the overall capacitance, the grouping is increasing the value or decreasing the value.
Increasing.
So every time, remember that parallel grouping always supports the increment of the value. So we do parallel grouping when we want to increase the value. Okay. So for n identical capacitor, the sequence is inch. Okay, I hope this is clear.
Yes, sir.
So do one small exercise. So we have given three capacitors. You go to market, you buy three identical capacitors C. Tell me what are the possible C equivalent by all various combination. What you can, how you can connect and get the various answers. So tell me all the answers possible. Because it's three, I hope you can do all the permutation combination. Because after 4 and 5, it becomes really complex. So what are the all the possible ways in which you can achieve this combination? Tell me. One answer or two answer you can say directly. If all are in series, if all are in parallel, right?
So if all are in parallel, then 3C, and if in all are series, then C by 3.
So these two answers are perfect. Now, can we get something more by
Yeah.
tweaking the configuration and getting something?
Like two in parallel, one in.
Yeah. Do it.
Will it be C?
Only C.
Yes, maybe.
I don't think so. So one is all in series. Okay, that's fine.
Yes.
One is all in
Sir,
parallel.
3C by 2.
Yeah, that's also correct. And one more. I think just one is left.
So 3C by 2.
And this is also, no?
Yeah.
How much is this?
The second one is 3C by 2.
Yeah, this is 3C, right?
Yes.
C by 2. Yes. This is how much? 2C by 3. Because the parallel will give you 2C and 2C and C will give you 2C by 3.
Ah, yes.
Understood?
Yes.
So with the three capacitor, you can create so many varieties. Imagine what you can do with 4. So try all possible configuration with 4. I think up to 4 is manageable. You can manage. Find all possible combinations. can take the clue from the left side. On the left, you know how to arrange 3 in all ways. Then you can see that how I can add 1 extra in various possible ways. I mean, there will be too many. So you have 4 answers here. Imagine you want to add 1 extra. What are the ways in which you can achieve? Yeah, tell me.
Then I got 5 combinations.
5 combinations. Okay.
4 series, 4 parallel,
I can see
3
many more.
series, 1 parallel.
You will get many more. So all 4
Yes.
series, right? Now what is the answer?
C by 4.
And all 4 in parallel.
4.
I hope everyone is getting this part at least.
Yes, sir.
So now I'll pick this one, the 3 one. And the 4th one I can bring it here. I'll pick the same one. I'll bring the 4th like this. I think this is what I can do. What is the answer now? This we know. This answer was 3C by 2, right? Up to the 3C by 2 and C. Up to here it is 3C by 2. We know this from here. Or you can do it again. So find this value. Tell me. Tell me the values of each part.
First will be 3 by 5.
So 3C by 2 into C upon 5C by 2. Yeah, 3C by 5.
Yeah.
Ready? This one? C by 3 and C, which is C
4
by
C by 3.
C by 4. I don't know, my bad. Sorry. C by 3, yeah, 4C by 3, correct. Okay, so taking this, we can create this. Now, if I choose this one to play with, I can add 1 extra here. I will not put in parallel because it is already there here. Now, what is the answer?
This will be 3C by 4.
Same answer, 3C by 4, right?
Yes.
Okay, then you can take this one and play with.
2 series, 2 parallel.
Yeah, right. So this is 2C and this is C by 2, which is 2C by 5.
Yes, 2C by 5.
And you can play one more time.
Ah.
So 2C by 5 and C in parallel, right? No. This is
2C by 3.
3C by 2. 3C by 2 and C. 5C by 2.
Yes.
You have to first simplify the below one, which is 3C by 2. And 3C by 2 will be in parallel with C, which you have just added, which is 5C by 2, right? Can we do something more? No. Now after this, we have left with one more combination, but I think that will give the similar answer. Yeah, if I pick this one, so we can create something like this: 1, 2, 3. This is done somewhere. No, it's not done. This is how much? C, C, 2C, and C by 2. 2C by 5, right?
So this is done.
No, no, no. This is C, C, 2C. 2C and C by 2. 2C and C by 2 become 5C by 2. This is done. Where?
No, 2C by 5.
Oh, 5C.
Yes.
C, C, and C by 2. C, C, C by 2. How much is that? All are in parallel?
Yeah.
2C plus C by 2. Yeah, 5C.
So
If you put in series, it will give you same something. Yeah,
I think there's one more, but I'm not sure.
yeah. Maybe something it will
At the
repeat also.
bottommost right corner, we have this 2 capacitances in parallel. So we take that same arrangement and then we connect it to another identical arrangement of that sort.
Yeah, correct. That's correct. So that is also possible.
Mhm.
Like
Yeah.
this. This is C 2C, 2C, which is C. Correct?
Yes, sir.
Yeah.
So we really have a large number. How many we have? 1, 2, 3, 4, 5, 6, 9. Maybe we can miss. So generally, in reality, if they will ask you this question, they will never cross 3. 4 becomes really cumbersome, and 5 is beyond scope. So this is the basic series and parallel combination. So I will revisit the directed questions, okay? Because we know the basic formula of series and parallel. So let's revisit the questions again. So this is what we had done earlier. K1, K2. So at every interface, you can imagine a boundary. Okay, like this. You can also think this as because if you move from one plate to other plate, how will walk? We'll cross the entire K1, then we'll land into K2, then we'll come here, right? So these two are in series combination or parallel combination. Which combination are they?
Series.
Definitely, because every medium comes one after the other. They don't come, or you can say every medium is not extending between the plates. So they are beginning at one plate, coming to an end. Then something else begins. It goes further, and then we reach the other plate. So a given dielectric is in series in parallel. We understand this way. Okay. So this you can resolve into 2 capacitors in series combination. And every capacitor is a parallel plate. So we can write C1 equals to K1. Let's this is D by 2. Here I say, so what we can write C1 equals to K epsilon not A. A is full A. but D becomes D by 2. Understood?
Yes.
And C2 becomes and we're done. I generally take epsilon naught A by D as C naught because it gives me flexibility of writing with ease. And at the end, I'll substitute the value. This value I always call C naught. So instead of writing this cumbersome expression, we can just write C naught. And for series combination, what is the C equivalent? That's it.
Yeah.
So C equivalent we can write as C1, C2, which is 2K1 C naught, 2K2 C naught, right? Upon 2K1 plus K2 into C naught, isn't it? So what we are left with 2K1 K2, K1 plus K2 into C naught. That's it. Pretty easy to solve. We have solved earlier. Now it's the method of circuit. It's easy. And eventually you can write like this. So you can find K equivalent as now suddenly you find the need to find the charge also. So redraw it. Connect with a battery. And because they are in which combination? Series combination. The charge appearing on the plate will be same, isn't it?
Yes.
So, okay, but the question is how much is V1? I want potential, or if you want, you can find the Q directly. So simple rule is because these are in series combination, so I can and because they are in series, so both will have same charge. So finding charge on one plate, or finding charge on the other plate, or finding charge on the combination is going to be same. Because even if I replace by C equivalent, the battery will provide the same charge.
Yes, sir.
So instead of finding on the left circuit, can you find on the right circuit? So that's easy. The answer is E equals to CV,
Yes.
and we know how to find C equivalent. Or in fact, we have the answer. How much?
2K1,
K1,
K2.
K2, K1 plus K2.
Same.
Epsilon naught A by D into V. It's a big answer, but with ease, right? And because charge is going to be same answer, so it is not required to find on the individually. You can just reduce it to one, find the answer there, and then that will be your answer. Is this clear?
Yes.
So getting this answer, what else you can ask? Yeah, now see the problem is because we got the answer. You may need to answer the voltage of each plate. So voltage of each plate we can write as Q by C1. In a way, it's a very beneficial because you know Q, you know C1. Simply substitute, we get the answer, isn't it? So V1 we can get is how much? 2 K1 K2 K1 plus K2 epsilon naught A by D into V upon, and C1 we have written somewhere, I think 2 K1 epsilon naught A by D. This is entirely concept 2 K1. Concept. So we got a V1 equals to how much? How much?
K2V upon K1 plus K.
It is simple answer, right? But writing this way is not good, right? So Now you need to know how to write it faster. Like, do we really need to write all this? The answer is no. In circuits, we have many tricks. So let me introduce you the first trick of circuit. Right now, we are not going to do the circuit, but just because it has come, so let me give a better perspective. So the future is going to be really easy. The first lectures are actually difficult. The basic method. If you can master it, probably you can master capacitor. The rest are easy. So these are the full-fledged rules, and there's a name for it also. And for that, there is no need to solve anything. You can directly tell the answer mentally. So if we have two capacitors, whether you feel something between the plate or not feel, that's not our concern. C1 represents the total capacitance, okay? The net value. You may fill with some dielectric. Okay, C1 represents the net value, including the dielectric. So this the D was the separation and all. What remains the same in the series combination Q? Isn't it? So the heading name, okay, the name of the topic is called voltage divider rule. Because the voltage is getting divided between the two capacitor. So how much it will contribute to each? That's the question. So I want to know the value across each value, capacitor. Assuming that the charges are same. If it is not same, I cannot use this formula. So we know that the voltage V1 we can write as Q by C1. Again, I hope you remember this triangle. I had drawn a long time
Yes.
back. Q equals to CV. So charge is important. Q, CV. Q equals to CV, C equals to Q by V, and V equals to Q by C, right? So similarly, we can add V2 equals to how much? Q by C2. And we know charge is going to be same. So V, what is the ratio of V1 by V2? It's inverse ratio.
V2 by C1. Yeah.
Well, again, by the logic of ratio and proportion, the V1 will get how much? C2 by 1 plus 2 into V. And V2 will get C1 by 1 plus 2 into V. Is this clear?
Yes.
Yes.
And here the A and D are same. So the ratio of capacitance will be ratio of dielectric constant, right? Luckily,
Yes.
because everything else is same. Absolutely not A, D, all are same. Okay, if you are not getting it, I'll just start completely. Then you can cancel out. And that is why, in this particular case, when you were solving this question, so V1 is what? K2 by?
Okay.
No need to solve it. Just remember the voltage divider rule. It is the inverse relation, right? So just knowing the voltage divider rule, which is this one actually. So when charges are equal, then voltage will be in the inverse proportion to the charge. Capacitance, right? What does it mean? That the voltage across the smaller capacitance will be more. That's logical, because if you have a small capacitor with less ability, and if you give more food to eat, he will say, "I'm more stuffed," isn't it? So if you give one slice of bread to a small toddler, and if you serve yourself 4 pieces of bread, you may be still hungry after 4 slices. And that small toddler will be totally stuffed after one bread. And he will tear apart many pieces here and there. You can see that if you have the scope. Understood?
Yes.
Yes.
So there are many ways of thinking. You can think like a capacitor is like a bucket, and the capacitance is like a base, the area of the base, and the charge is like a water which you pour to the base. So if I have a two capacitor with a different capacitance, so we take capacitance as a base, and then if you have, if you fill both with same charge, same water, in which case the rise will be more. So if you pour same amount of water,
C2.
then C1 will be very less.
Yes.
This is the V1. It's like a height. You can think as a simple formula like, if you know basic mensuration chapter, you can get the answer. It's pretty easy.
Yes.
So giving same charges, giving same water. Capacitance is like a base. So the one with less base will have more height, and height is always representing potential. Okay. To
Yes.
correlate, you can think as potential energy. A gravitational potential is height. Okay, you can think this way. And this formula is also very popular to remember the relation. So Q equals to volume of water is how much? Area of the base into height. Okay, don't know the formula of volume. Anyway, so you can remember like this. You know it is really good. So if you want to, if you know the height and if you know the base, what is the volume? The product of the height and base, right?
Yes.
And if you know the water, if you know the volume and if you know the base, what is the height?
Volume by base.
Volume by base.
Logical. And if you know the height and if you know the volume, what is the base area?
Volume by.
It's common sense. I hope you can see the capacitance in this way, and it's pretty easy. Okay. So if
Yes.
all buckets are given same amount of water, then the bucket with the least base area will have the maximum height. That's logical.
Yes.
Okay. So this water analogy is very powerful to help you visualizing the capacitor questions. Okay. All right. So if I give you multiple capacitor with same height, what does it mean? What is same for all?
Base.
Come on. Same height is what?
Same
Potential.
Same potential.
Potential.
Okay. So if they have same potential, they have same height. So which capacitor will have maximum water?
The one with maximum base.
Exactly.
Yes.
Logical. And see, this is what we have done here. In parallel combination, what is the same?
Potential.
Potential. So the height is same for all.
Yes.
Yeah.
So which capacitor will get maximum water? I mean maximum charge.
The one with highest capacitance.
High capacity.
So in parallel combination, if I have two capacitor, one with high capacitance, other with low, then charge will go proportional to the base. Yes or no?
Yes.
Yes.
So can you say the charge will go proportional to the C value? Yes or
Yes.
no?
Yeah.
So that's called the, okay, that's called what? It's called the charge divider rule. Yeah, I'll come to that next part. This part is clear. The voltage
Yes.
divider rule. It's pretty easy. Practice enough to make this all mental, like mental means mentally. I mean, you should be able to do it mentally, not, I mean, required any pen or paper. If circuit we cannot solve with without using pen and paper, then basically we are not solving circuit. We are doing some bonded labor, okay, which I don't know. So if you really want to master circuit, there are certain rules I'm going to give you. These are secrets, top secrets. And after learning these top secrets, you can do it very efficiently. The next is called charge divider rule. And this we generally do it for the parallel circuits. This is not at all right. So now what we have is we have two buckets with base C1, C2. And you can see the buckets are in parallel. So which means they must have same. Parallel means
Height.
they
I
must
mean,
have
voltage.
the same potential, right?
Potential.
Now the water is coming. And you have two buckets which are connected. So this is called the it is called the communicating vessel. Chapter of fluid mechanics, you study communicating vessel, right? The
Yes.
vessel can communicate. How
Yeah.
they communicate? Of course, they don't talk on WhatsApp.
Through it.
So you connect a tube, right?
Yes.
So now, the moment you start pouring the water, it will come to the same height. And no matter what amount of water is coming, the height remains same in both cases, right? So let's say we have sufficient water to fill up to this height. So because the vessels are communicating, which means they are in parallel, what remains same? In communicating vessel,
Hi.
the water remains same. The height remains same. Yeah, that's correct. The height
Yes.
remains same. My bad. The water is not same. So if height is same, then what is not equal?
Capacitance.
Base.
The amount of water. So it will get different water, no? Q1 and Q2.
Yes.
Because they have same height, which means same potential. Yes or no?
Yes.
Common sense. Okay. So the first bucket will get how much water? Given that total water poured is Q. So Q1 plus Q2 is Q. So the total water is given, right? I want to know what is Q1, Q2. I know that the total amount of water is Q1 plus Q2. That's common sense. That's called the KCL here, right?
Yes.
Yes.
And we know that Q1 by Q2 will be proportional to what? The base area.
C1 by C2.
Yes.
Because more the base, more the amount of water, because height is same.
Yes, sir.
But you can see potential difference is same. That's why, because the potential difference is same. If you think this way, you can say Q1 by C1 is equals to Q2 by C2, because V is same, isn't it?
Yeah.
And therefore, the ratio of charges in the proportional ratio of capacitance, which is again logical. If you draw the water analogy, no.
Yes.
Yeah.
So the total amount is given, the ratio is given. So as per the logic of a ratio and proportion, what is Q1? It is C1 by.
C1
C1
plus
plus
C2Q.
So these two rules are sufficient to solve any JEE question with ease. I mean, you can do it almost mentally, 99% question, except few question you need to solve. Just Okay. So the two rules are okay, really nice rule. If you the moment you see a circuit with parallel combination, and if you know the incoming charge, you can easily divide with ease. Okay. So let's say if I give you a simple question like this. So there's a charge coming in, which is 24 microcoulomb. How much each will get without solving? Can you tell me the answer mentally? 20 is not good. 20, make it 20. That will be better. Right? So how much is the upper one we get? Hello, hello.
8.
8. So it will get in the same proportion 2 by 5, which is 8, right?
And down one will get 12.
12.
So simple, without any effort. Anyway, but this is not our present job. We'll come to that again in a circuit when we solve actual circuit. Right now, our job is to solve the find the C equivalent of dielectric field parallel plate capacitor. So I will go to the next question. This series is done here. If you want, you can keep on using. So we'll come to this question, which we had solved through all the hard work. So sometime we can take the brighter color also. This looks better or the matte finish? I think change is better, right? We should keep on changing them, not to get bored with color also. Okay, so we have these two dielectric of constant K and K2, and each occupying half of the area. Now, if you look carefully, every dielectric is spread or is spanned between the two plates touching both the plate, right?
Yeah.
So the potential difference across every dielectric is same as the potential difference across plate.
Yeah.
So actually these are having same potential difference. So we can say these are in which combination?
Parallel. Parallel.
So we can draw two parallel capacitors. We are done. C1, C2. So you know how to find a C equivalent. C1 plus C2. And by the way, what is C1? K1 upsilon naught. Tell me next.
A by 2. D.
A by 2.
Upon D.
K.
Which is nothing but the K1 by 2 C naught.
Yes.
And similarly, I can add K2 as K2 C naught by 2, just like this.
Yes.
So I'm done. So this will become K1 plus K2 by 2 into C naught. So easy. Imagine the effort taken here. Where? Oh my God. Eventually we got the answer. Anyway. I hope this is simple.
Yes.
So C2 is K2 C naught by 2. I mean, sorry, C equal to we got the answer. if you want to, and now suddenly you got interested because we give charge q to the plate, which is same as charge given q to the circuit, and it will divide in which ratio?
K1 by K2.
It will divide in the C1 upon C2 ratio, which is similar to Q1 K2.
Yes.
So without much effort, I can directly tell you charge on each part. So this part will have Q1, this part will have Q2, and we can find Q and Q2 directly. But why that method was necessary is to understand the benefit of this method. So you wouldn't have appreciated this method unless you would have not seen that method. Nevertheless, so Q1 you can attest. Tell me quickly, K1 by
K1 plus K2 into
Into
K2 by K1 plus K2 into Q.
guys are expert now. And once you get Q of each plate, you can find the electric field due to the plate above, due to the plate below, where the formula is Q by sigma by epsilon naught, right? So it is
Yes.
Yeah.
Q1 by A by 2 by epsilon naught, something like that.
Yeah.
So you can find field also, and you can do everything. Okay. So those questions are not my concern. I have some concern here, which I'll come to very soon. Before that, I'll solve one more question. So now comes this tricky question, which is very famous, very, you can say, peculiar, typical, everything. Okay, you want bright color? So what I can put here to make some nice color of a country, flag of country. So which country will have this two color? And these two colors? Okay, I can take a yellow, which is very typical. So country with a red, blue and yellow. Which country is this? Maybe I think Spain or some European country. Maybe some Kenyan country. Anyway, so a red color means the country will have some communism influence, or communist party is ruling. So the red color comes. The rest is for the peace or some harmony. So it may be some European country, I can guess. Okay. So now we have three capacitors. I mean, basically three dielectric, and of course this is A by 2. Can you find the C equivalent?
Yes.
So now can you tell me which one is series, which one is parallel?
Sir, I think K2 and K3 are in series and together
Just a
their
minute.
combination is in parallel.
Yeah, tell me once again.
Sir, I think K2 and K3 are in series and their combination is in parallel with K1.
But the plates are right and left. How they can be in series?
Sir, I think K2, K3 are in parallel.
Hmm. And K1 is in series.
I think.
Okay. Any other opinion?
Sir, even my answer is the same as Mutha's.
Yes, sir.
Okay. So now the answer is, it's very interesting problem, and you must understand that on the right hand side you can see there are two facing dielectrics, so the charge will distribute here.
Yeah.
Yeah.
And exactly parallel to this line, the other plate must have same distribution. So these two are also different. Understood? So basically, of course, it's not easy to understand.
Means they are divided kind of.
Yeah, you have to break the K1 into two parts. The upper K1 and K2 will be in series. The lower K1 and K3 is in series, and then combination is in parallel. So the actual shape is the K1 and K2. If I say this is C1, this is also C1, but this is C2 and this is C3. That's two.
But sir, I didn't get why we did so.
Yeah, tell me.
I didn't get why we like made the
Yeah,
parts.
correct. See, imagine if we have electric field, if you assume the entire charge to be uniform on the left plate, then the field here will be E by K1,
Yes.
correct?
Yes.
And then you walk ahead and then it becomes E by K2.
Yeah.
So if you move this path, you will get the answer how much? E by K1 plus E by K2 equal into D is V, potential difference, right?
Yeah.
But if you move like this, what will happen? E by K1 plus E by K2, K3, sorry, into D equals to V. Is it possible to have two values with the same answer?
No.
This is not possible, right?
Wow.
So E must change, right?
But
What is happening? What is happening is the field will change much before any division will take place. It means the plate will distribute its charge so that while going forward, there's no need to change the value. I mean, the field of that plate must remain same throughout. Okay. So what will happen is the charge on this part and this part will divide because of this side. Just okay. So what is happening, that the charge will distribute here itself, and it will see that where it is getting divided. So it is not possible that every charge is flowing here and this will divide here. This will never happen. There should not be any division of field actually. The field lines must move in a similar fashion. So let me give you some other example. Let's say K2 is 2 and K3 is 3 and K1 is 1, which means it's air actually. Okay. Now what will happen? The field of the plate will be here E, here also E. If you assume the charge is uniformly distributed, then this is the condition.
yeah.
If you assume if it is not uniformly distributed, then the E here, because we know that answer will become, the answer here will become E by 2, here become E by 3. So in which case it is going to be weaker, the bottom or the top?
Bot.
The bottom.
Bottom. So because it will decay by large values, what will happen? The plate will do a kind of jugaad. It will bring a more charge here, I mean, a more charge here and less charge here. Why? So that here the field is E1 and here the field is E2. Now, if you walk like this, in the beginning it is less drop, right? E1 by K1 into D by 2. But here the drop is how much? E by, oh, this is some, no, wait. This is K only. So this is E1, so drop is nothing. So if you walk D by 2, how much potential drop will be there? E1 D by 2. But here it is E2 D by 2, isn't it?
Yeah.
Because K is 1, it's like nothing. But now it will decay by less value. This will become E1 by 2. But this will become E2 by 3. So to get the right answer, like to get the same potential difference, I must manipulate in order to, even after the decay, the sum of the net potential remains same in the top and the bottom. Understood?
Okay, yes.
So what happens whenever we have the change of dielectric, the field will change its value, and the facing plate will decide how many field will be created by the plate. Okay. So although we have physically one plate, but it is having multiple distribution across the various patches, and therefore we have multiple electric field that the plate itself creates. Okay. So how to say it? It is like it's a big thali with multiple, you can say cavity made to keep multiple dishes. So thali is one, but you have multiple objects, I mean, dishes. Understood?
Yes.
It's particular.
Yes.
Okay. So the rule is you have to break. Now, what is C1? What is C2? Let me remove this. This is not required. Anything is required. Let me make it simple. Ah. So the C1 will be how much? K epsilon naught, but it will be only A by 2 area, right? And it is only D by 2 width, right? So this becomes how much? K1 epsilon naught A by D. Luckily, it's similar, right? So C1 is what I wrote here. K1. Okay. So C1 you can write as K1 C naught. Is this okay?
Yes.
And why C1 C1? Because it's the same, right? Half half. So same. So similarly, we can say C2 is K2 C naught and C3 is K3 C naught. Understood? And therefore, now you can get the answer because the top two are in series, bottom two are in series. So C equivalent I can write directly. The top two and bottom two will add up, right? They are in parallel. But the top two will be how much? 1, 2, 1 plus 2. Bottom two, 1, 3, 1 plus 3. And they are in parallel, so we can add them. So we are done. So what are we going to get? After doing all the manipulation, you get 1, 2, 1 plus 2. Of course, this is not a dance movement, but you can say 1, 3, 1 plus 3 into C naught. And if you want, you can substitute. But the really interesting part is I can get the K equivalent, right? And the value of K equivalent is how much? 1, 2, 1 plus 2, 1, 3, 1 plus 3. All right, this is clear, everyone?
Yes.
I'll just give you one question for eliminating the doubt, like how to separate it when you get confused like this. One, the next will be okay. So now this is just for, example, no need to solve because nothing like this will come. Okay. So can you just draw the circuit and then I'll draw, you can magic later on. You think of drawing the circuit, what kind of circuit you are expecting, and then what you get exactly, I will show you. So tell me the answer. Draw this. I'll just draw and you can match. So I won't continue lecture for long. I mean, I'll end by 12, 8:20 itself, next 5 minutes. I have to attend one Visarjan actually, to go for Visarjan. Done, I hope so. You got the idea. So what you need to do is just look at the interface and draw it a line. So every horizontal interface will let you draw one line. So in total we have 4 layers, 1, 2, 3, 4, and all will be in parallel. So the circuit will be K1, K2, K4, K1, and area will be quite complex, K1, K2, K4. I just mentioned the name of the dielectric. Then 1, 2, 5, K1, K2, K5. Then again next is 1, 3, 5, K1, K3, K5. The fourth one is 1, 3, 6. So this will be your circuit. I mean, of course, no need to solve. No need to solve. Just to understand that, okay, how the division is done. So every horizontal line, the gap which you see, what you need to do is just cut from there and you make parallel slices till you get all exhausted. Okay. And then how many types of charge distribution will get on the plate? The answer is there are 4 types of charge distribution.
4.
It means, yeah, it means whatever charge is coming here will divide Q1, Q2, Q3, and because the rest are in series, so Q1 will be here also, here also. Q2 will be here also, here also. Q3 will be here also, here also. And Q4 will be here also, and here also. Okay.
Yes.
So with this, I'll end today's session.
Sir, on Sunday, can you take the doubt section then
Yes, yes,
after
definitely,
class? Okay.
definitely. You can come. In fact, you can come. What is tomorrow? Tomorrow is like. So if you want, you can come around 5:30 tomorrow also. 5:30 to 6.
No, I have actually class.
No problem.
I will come on Sunday.
Fine. Okay, guys. So now you can revisit the problems and you can see the circuit method of solving question. It will be really easy for you. It's not going to be difficult. And you can find everything, charge, voltage, and whatever. Okay. So the next we are going to do is something called spherical capacitor and cylindrical capacitor. I would have done today only, but okay, anyway. Bye, guys. Take care. Good
Thank you,
night.
sir.
Thank you, sir. Good night.
Thank you, sir.